So today we're going to be looking at the full force versus extension profile of a material. We previously talked about what these graphs look like in the region where Hooke's law applies, but now we're going to be looking at the full profile of these graphs. A normal force versus extension graph for most materials will look something like this, roughly. And there are some key points on this graph, so let's discuss them. Point number one on this graph is your limit of proportionality. And this is basically where Hooke's law no longer applies. So at forces beyond this force, Hooke's law will no longer apply. Point number two, which may be somewhere around that region, is something called the elastic limit. And now what this means is, at this point, the material will no longer have elastic behavior. Now what is elastic behavior? So this means that when a force is applied and then removed, the material should return to its original length. So basically, after this elastic limit has been reached, if you apply a force and then remove that force, the string or the material will not return to its original length. Point three is your ultimate tensile stress. And this is the maximum force or maximum stress you can apply to the material, or that the material can withstand before it breaks. And point number four is your breaking force, which is basically the maximum extension of your spring or string or material before breaking. So it can't extend further than point number four before it breaks. Now we've talked about elastic behavior, which is the kind of behavior that this material exhibits up to point number two, which is your elastic limit. After point number two, the material exhibits plastic behavior. And this is when the material gets extended permanently, which is basically where, when the force applied is removed and the material doesn't return to its original length, it will return to a length that is usually longer than what it originally started off at. Now, in this sort of topic, there may be a couple definitions that you need to know. The first may be something that is called brittle, and this is something that has a very small plastic region, which means that you can't extend it a lot without it breaking. And the force versus extension profile for a brittle material may look something like this, where it has a very short plastic region. Another term that you may need to know the definition of is ductile. A ductile material is, after the elastic limit has been reached or has been passed, for a small increment, which is a small step or a small change in force, the material will have greater extension. And a property of ductile materials is that they can be drawn into wires. And these kind of materials have a very large plastic region, so they may look something like that. So the last thing I want to talk about is elastic potential energy. And this mainly refers to energy stored by a material when it's being stretched while Hooke's law still applies. And the elastic potential energy stored in a wire, let's say that's been extended by this value of A here, is simply equal to the area under the graph from the origin to that point A. So your equation for elastic potential energy is equal to half F x. As you can see, it's just the area of a triangle. Remember that we know that F is equal to kx, so we could also write this as a half kx squared. The units for energy is always in joules, units for forces in newtons, your unit for extension has to be in meters, your spring constant has to be in newtons per meter, and again your extension has to be in meters here. And this equation also stands not just for materials that have been stretched, but for materials that have also been compressed, let's say a spring for example. Now the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.